I guess it's my iron deficiency anemia again. Yep, iron deficiency is common among people our age, teens. Now, you may have heard about the relationship between oxygen and hemoglobin binding affinity, which is how much oxygen and hemoglobin is attracted to each other. But you may be wondering, what is oxyhemoglobin? But wait a second, I'll explain everything. This is a red blood cell, and in this red blood cell there is hemoglobin, which is a protein tetramer, and in this hemoglobin there are 4 hem groups which contain iron, which is why having enough iron is vital for preventing iron deficiency anemia. And these individual hem groups bind to oxygen. When oxygen is binded to hem groups, this hemoglobin is now called an oxyhemoglobin. While there are several factors influencing oxygen and hemoglobin binding affinity rate, the Bohr effect plays a significant role. The Bohr effect is described in this curve called the hemoglobin dissociation curve. The x-axis represents how much oxygen is present in the blood, aka the partial pressure of oxygen. The y-axis is the quantity of how much oxygen is bound to hemoglobin. The Bohr effect occurs when there is an increase in temperature or decrease in pH, which means it's becoming more acidic, or increased partial pressure of carbon dioxide, aka the concentration of carbon dioxide. All of this can decrease the oxygen hemoglobin affinity rate, but oxygen release to tissues increases. Therefore, when the Bohr effect occurs, the curve is shifted to the right when those factors increase or decrease as such. So next time you see a friend with iron deficiency anemia, just tell them about the Bohr effect, or maybe later.